Your truck has 80,000 miles on it. It runs fine. Then one morning, you hear a tick. Not loud, not alarming, just a quiet little tap under the hood. You think maybe it needs an oil change. Maybe it is nothing. 6 weeks later, you're staring at a $4,000 repair bill and a mechanic telling you your engine collapsed from the inside. This is not a rare story. For hundreds of thousands of GM truck owners, this is exactly how it goes. And the worst part, the engine did not fail because of neglect. It failed because of a design that was known to have problems, and it kept getting used anyway. Let us talk about what is actually happening inside these engines, why it matters, and what you can do if you own one of these trucks. The engine at the center of this problem is General Motors' 5.3-liter and 6.2-liter V8 engines found in trucks like the Silverado and Sierra, and in SUVs like the Tahoe and Suburban. These are some of the most popular vehicles on the road. Millions of them are out there, and a significant number of them are carrying a ticking time bomb inside the valvetrain. The failure is called active fuel management lifter collapse. Active fuel management is a fuel-saving system General Motors introduced to help these big V8 engines get better mileage by shutting down half the cylinders when the truck does not need full power, like cruising on the highway. On paper, it sounds smart. In practice, it has been destroying engines for years. Here's how it works, and more importantly, here's where it goes wrong. Inside a traditional V8, you have 8 cylinders firing in sequence. Each cylinder has lifters, small hydraulic components that sit between the camshaft and the valves, opening and closing them at the right time. Active fuel management adds a special set of collapsible lifters to 4 of those cylinders. When the system decides you do not need all 8 cylinders, it cuts fuel to those 4 and collapses the lifters, so the valves simply stop moving. The cylinder goes quiet. The engine effectively becomes a 4-cylinder until you need more power. The fuel savings are real but modest. The problem is, what happens to those collapsible lifters over time? The active fuel management lifters are more mechanically complex than standard lifters. They have more moving parts, more internal oil passages, and they depend heavily on oil pressure and oil quality to stay functional. When they work perfectly, great. However, they have a documented tendency to fail, and when they fail, they do not just stop working. They break apart. Pieces of the lifter can scatter into the engine, and that can cause catastrophic consequences. When that happens, you are not just replacing a lifter. You are often looking at cam damage, valley damage, and sometimes full engine replacement. The failure pattern is consistent across thousands of owner reports. It usually starts with that quiet tick at startup. The tick might go away after a minute once the oil pressure builds. Owners assume it is normal. They keep driving. What is actually happening during that tick is a lifter that is not receiving enough oil pressure or beginning to wear abnormally. Over time, the wear gets worse. The tick gets louder. Then, one day, the engine misfires. The check engine light may come on, or the truck can go into limp mode on the highway. By that point, the damage is often already done. Mechanics who work on these trucks regularly will tell you they see this job constantly. It is not an edge case. It became one of the most common and most expensive repairs associated with GM's V8 trucks from 2007 onward, with heavy complaints continuing well into the following decade and beyond. Now, here's where it gets frustrating from an ownership standpoint. General Motors has known about active fuel management issues for a long time. There have been technical service bulletins, official documents sent to dealerships that acknowledge specific problems and provide updated repair procedures. That's not a conspiracy theory. That's standard industry practice. But a technical service bulletin is not a recall. It does not mean General Motors is paying to fix your truck. It means the dealership now has updated guidance on how to handle it when you bring it in and pay for the repair yourself. Some owners have had luck getting coverage under warranty or goodwill assistance, especially on lower mileage vehicles. But many others, particularly those who bought used trucks or whose vehicles were just outside warranty, have been left holding the bill entirely. And that bill is not small. A proper active fuel management lifter replacement on a 5.3-liter typically runs somewhere between $3,000 and $5,000, depending on the extent of the damage, the shop, and what else was affected. If the camshaft is damaged, which it often is when a lifter fails hard, you can add more to that. Some owners have been quoted north of $6,000 or $7,000 for a full repair. So what options do people actually have? The most popular solution in the truck community is to disable active fuel management, often called AFM, entirely, and replace the AFM lifters with standard solid or standard hydraulic lifters that do not have the collapse mechanism. There are kits available specifically for this purpose. Many shops that specialize in these trucks do this job regularly. You lose the cylinder deactivation feature, but you gain a far more reliable valve train. There is also an AFM disabler, a small plug-in device that prevents the system from activating without any physical modification. This is a lower-cost option, and it stops the AFM lifters from cycling, which reduces wear. However, the lifters are still in the engine. They are just not being used. Whether this fully eliminates the risk long-term is something owners debate. The general consensus in enthusiast communities is that a full lifter swap is the more permanent fix. If you are buying a used GM truck and you want to avoid this entirely, there are a few things to look for. Later model year trucks sometimes received updated components. Some owners specifically seek trucks with the 6.2-liter in certain configurations, or they look for trucks that already had the active fuel management system deleted by a previous owner or by a shop. Knowing the service history matters more than usual with these engines. One thing worth saying clearly: not every GM truck with the active fuel management system has failed, and not everyone will. Plenty of owners have driven these trucks well past 150,000 miles without major issues. Driving habits, oil change intervals, oil quality, and a degree of mechanical luck all play a role. Short trips that do not allow the engine to fully warm up seem to correlate with faster lifter wear in many accounts. Using a high-quality, full synthetic oil and keeping up with changes more frequently than the minimum recommended interval is widely considered one of the better ways to extend the life of these lifters. But here is the honest truth: you are relying on a system that has a well-documented failure rate, and when it fails expensively. That changes the risk calculation compared to buying a truck with a more conventional valve train setup. General Motors has moved away from active fuel management in recent years, transitioning toward a different system called dynamic fuel management in newer trucks. Whether dynamic fuel management proves to be more reliable over the long haul remains to be seen. It is still relatively new in terms of real-world longevity data, but the very fact that they changed the system says something about where the old one stood. For owners of trucks from the active fuel management era, the lesson is already written. The system was a fuel-saving compromise that came with mechanical costs that were not fully transparent at the time of purchase. Owners found out the hard way at the worst possible time, usually right after the warranty expired. Here is the takeaway. If you own a General Motors truck or SUV with a 5.3-liter or 6.2-liter V8 engine and active fuel management, do not wait for the tick to get loud. Have the system inspected. Talk to a knowledgeable mechanic about whether disabling or deleting active fuel management makes sense for your situation. Stay on top of your oil changes and do not ignore early warning signs. If you are shopping for one of these trucks, factor the potential repair cost into your budget. Know what you are buying. A truck that looks perfect on a used lot could be one bad morning away from a $5,000 repair. The engine in a half-ton truck should outlast the payments. When the engineering meant to save a few miles per gallon ends up costing you more than a transmission replacement, something went wrong long before you ever turned the key. Know your truck, know its history, and do not let a quiet tick turn into a catastrophic surprise.